Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. Students, in this video series we are going to discuss the case studies on three-dimensional geometry. These case studies will be very helpful whether you are a CBSE board student or whether you are an ISC board student. We are going to discuss various concepts on 3D geometry, and it is going to enhance your skills how to tackle MCQs based on these case study. So let's move forward and discuss our first case study on 3D geometry. So students, here comes our first case study on 3D. A communication tower is being designed to ensure optimal signal coverage in a hilly region. The tower is positioned at point A234 and a signal receiver is located at point B, which is 578. The engineers need to align the tower's antenna along a specific direction to optimize signal transmission. The antenna's orientation is defined by a line passing through A and parallel to the vector which is given V vector. Additionally, a safety plane 2x plus y minus z is equal to 1 is defined to avoid interference with nearby structures. The engineers must calculate the direction cosines of the antenna, the equation of the line, the distance from the receiver to the safety plane, and angles between geometric elements to ensure proper alignment. Now for your ready reference, I have also mentioned few key formulas and properties like direction cosines can be found like this for a vector ai plus bj plus ck, and direction cosines are like this, and their square sum is equal to 1, which is also a property of DCs. Equation of a line, vector form is this, Cartesian form is this. Distance from a point to a plane can also be found like this by using ax1 plus by1 plus cz1 plus d upon root over a square plus b square plus c square. And angle between two lines for direction vectors b1 vector and b2 vector can be found by using cos theta is equal to this. Now this is our first case study, and on the basis of this particular case study I have prepared 5 MCQ as per the board standard. Now let's move forward and discuss our first MCQ based on this case study. So students, here comes our first question based on this particular case study. What are the direction cosines of the antenna's orientation having vector v vector is equal to 2i plus 3j plus 6k? As we have discussed the formula related to the direction cosines, which can be easily found by using a1 vector upon root over a1 square, a square plus b square plus c square, you can say, right? Simple. Now a, b, c are the coefficients of I, j, k respectively. Hence for the first coordinate is going to get by using 2 upon root over what? 2 square plus 3 square plus 6 square. Very simple. Now 2 upon root over 4 plus 9 is 13. 13 plus 36 is 49, which is equal to 2 upon 7. So first x coordinate is given by 2 upon 7, or we can say 2 upon root 49. So here we can see that two options are matching our answer, but we can write it like this: 2 upon 7, 3 upon 7 and 6 upon 7, as this may be a typo error. Not an issue in that, but we have understood how to tackle such type of question or how to find the direction cosines of a vector. Now let's move forward and discuss our second question. So students, here comes our second question. What is the Cartesian equation of the antenna's line passing through A and parallel to this particular vector? That means we have to find the equation of a line which is passing through a particular point and having direction ratio is equal to the vector v vector is equal to 2i plus 3j plus 6k. As we know that if we have a, b, c as our direction vectors and the point x1, y1, z1, which are the point basically through which a line is passing through, then we can simply say that our required equation is x minus x1 upon a is equal to y minus y1 upon b equals to z minus z1 upon c. Very simple. Now x minus x1, x1 is the point which is 2, 3, 4, 2 upon a. A is coefficient of this, which is 2 again, is equal to y minus 3 upon 3 is equal to z minus 4 upon 6. Very simple. Hence our required equation is given by x minus 2 upon 2 is equal to y minus 3 upon 3 and z minus 4 upon 6. And if we compare our answer with the given option, we can say that option number A is our correct answer here. Now let's move towards question number 3. So here comes our question number 3, which state what is the distance from the receiver at this particular point to the plane. So this means we need to find the distance of a point from a plane. First, let us write the equation of the plane like this: 2x plus y minus z minus 1 is equal to 0. And here we have a1 is equal to 5, b1 is equal to 7, or abc you can write out, c1 is equal to 8. Very simple. Now we can simply plug in these values here to find the distance. Basically 2 into a1, which is 5, plus 1 into b, that is 7, minus 1 into 8 minus 1 over root over the coefficient of x, y and z. So that is the coefficient is 2 here, 2 square plus 1 square and plus 1 square only. So hence our answer will be 5 to the 10. 10 plus 7 is 17. 17 minus 8 is 9. 9 minus 1 is 8 again. So 8 over root over 4, 5 and 6. So 8 upon root over 6 is our correct answer. Hence we can say that option number A is our correct answer here. Now let's move towards question number 4. So students, here comes our question number 4, which state what is the angle between the antenna's line. So here you require the antenna's line means direction of antennas from our previous question. So this question is linked with our previous question and the line joining this particular point A and B. So first we have to find the direction of what? Direction of AB, which is equal to what? 5 minus 2 3, 7 minus 3 4, 8 minus 4 is 4. So this is your direction of AB. Now what is the antenna's line here? So here you need to find the line of the antenna from the previous question. So for your reference, I have pasted this previous question here, which state what is the Cartesian equation of the antenna's line passing through this and parallel to this. So obviously antenna's line was parallel to this particular vector. Hence we can say that antenna line's direction is nothing but 2, 3 and 6. So antenna's line is 2, 3, 6. Now we have two directions here. One direction is of AB and another one is of antenna's direction, which is 2, 3, 6. With the help of the formula that cos theta equals to this into this, that is 3 into 2 plus 4 into 3 plus 6 into 4 over root over 3 square plus 4 square plus 4 square into root over 2 square plus 3 square plus 6 square. Very simple. So by using this particular formula, we can easily find out the angle between two lines. Now we have to simplify it further. This is 3 to 6, 6 plus 12 is 18, 18 plus 24 is 42, 42 over 16 plus 16, 32, 32 plus 9, 41. So root over 41 into 6, 6 is 36, 3, 3 is 9, 36 plus 9 is 45 plus 49. So root over 49 here. So we have our answer, which is 42 over root 41 into root 49. So hence our answer is 42 over root 41 root 49, which is not available in any of the option, but our answer is correct here. So I hope the concept is clear how to find the angle between two lines. Now let's move towards question number 5. So students, here comes our question number 5, which states if another line passes through point B, that is 5, 7, 8 with the direction ratios 1, -1, 1 and what is the condition for it to be coplanar with the antenna's line? We know that the coplanarity can be found when the determinant value of all the three direction ratios equal to 0. So hence we can write 5, 7, 8 and the dr of the antenna line was 2, 3, 6 and 1 minus 1, 1 equal to 0 here. Hence if we compare our answer with the given option, then we can see that 5, 7, 8, 2, 3, 6 and 1 minus 1, 1 is our correct answer here. So student, that was the last question of this particular case study. I hope you enjoyed this particular video as we have discussed various concepts on 3D geometry chapter. I have also prepared 1 marker questions online test for grade 12 student on all the chapters, and these 1 marker online test is going to enhance your skill how to tackle 1 marker question in your upcoming board exam. These online tests are free of cost and available on my website, which is udgamwelfarefoundation.com. You can easily access these free resources by simply login. I am going to share you the link in the description box. We are going to meet in our next videos with more case study on this particular chapter. Till then, goodbye and take care.